Hi, this is video 2 in the playlist where we're going to have a look through the AQA paper 1, and it's actually June 2018. So on the last video we finished at question number 10. From this video we're going to be looking at question number 11 onwards. Please do have a go at each of the questions, stop the video, have a go, and then compare your solution through. Okay, let's have a look then at question number 11. It says a large rectangle is made by joining three identical small rectangles as shown. And it says the perimeter of one small rectangle is 15 centimeters. Work out the perimeter of a large rectangle. Okay, the clue here, I think, you've got to be just a little bit careful about this, is that we've got a perimeter of 15. Now, I think you could probably do this using a little bit of algebra if you wanted to. However, I just preferred, when I looked at it, just to be a little bit more straightforward with it, because the thing that appealed to me is that this and this are the same, and actually it means then that the width of the table is half the actual length of the table. And that got me thinking, because if the perimeter is going to be 15, what it means is if I've got a table and it's 15 all the way around, if I make that 5, make that 5, make that 2.5, and make that 2.5, then actually that totals to 15. So actually I had my answer already, and it's just a case really of just adding up the outside edges to get my overall perimeter of the large rectangle. And when I added up all of those, I actually worked it out that it came out as 25 centimeters. Okay, so it's fairly straightforward to do a question like that. It is actually it is actually 4 marks, which I think is an amazing amount of marks for that particular question. But I guess it's one of those questions that you could go off a little bit of a tangent if you weren't too careful. Okay, let's move on then to question number 12. And question number 12, got to put these numbers in order from the smallest to the largest. Well, you can see there's a bit of a mix of numbers there. You've got a decimal here, you've got the rest of them are standard forms. So what I'm going to do is just convert them all to decimal. So the last one is straightforward, it's 0.07. What these negative numbers tell me is the decimal point has been moved along towards the left. So if this is 10 to the minus 4, the decimal point currently is there. Well, I'm actually going to move it 4 places. That's 1, 2, 3, 4. So the decimal point now ends up there, and I need to put a few zeros in place. So this particular number will have 3 zeros in it. Okay, next one is going to have 2 jumps, so that's 1 and 2. So it's going to have 1 0 in it, so 0.04. Okay, this one again, it's minus 4, so it's the same number, so that's 0.0006, and then obviously that last one stays as it is. So to put this in order, now because I have converted them, it doesn't mean to say that I leave them like that. I think the implication of this is that when you write your answer, you write them back out in standard form. Okay, so when I do that, my smallest is going to be this one, which is 6 times 10 to the minus 4. My next largest is going to be this one, which is 8 times 10 to the minus 4. My next one is going to be 4 times 10 to the minus 2, so this one here, and then my last one is going to be 0.07. Okay, hope that's all right for you. Let's have a look then at question number 13. And it says circle a volume that is the same as 15 centimeters cubed. All right. Again, be really careful about this, because if you were looking at a direct linear conversion, then it would just simply be centimeters to millimeters, and all I'm going to do, because I know that there are 10 millimeters in a centimeter, I just basically multiply by 10. Okay, so let's have a look then at centimeters squared to millimeters squared. Well, I'm going to multiply that by 10 squared. And then finally, if I've got centimetres cubed, which is what I'm looking at, to millimetres cubed, I'm going to multiply that by 10 cubed. So basically, the answer then is going to be 15 times 10 cubed. It's 15 times 10 cubed. Okay, so that's going to tell me that I'm moving the decimal point by 3 places. At the moment it's here. If I move it along 3 places, I'm going to get 15, 1, 2, 3. So the answer is going to be that particular one. Okay, I hope that's all right for you. It is only a 1 mark question, but I think it is worthwhile getting to grips with these sorts of questions because they do keep turning up on these sorts of exams. Okay, so on to question number 14, and it says patterns are made using straight lines and arcs. So you've got pattern A, which is 1 row. Now in pattern A, we've got basically 5 straight lines, okay? And with those 5 straight lines, we've got 1, 2, 3, 4, 5, 6, 7, 8 arcs. So we've actually got it in the ratio of lines 5 to arcs, and that's 8. Okay, and what we're being asked to do is continue on with this pattern until we get to a ratio of 10 to 9 of number of straight lines, number of arcs. So you need to be a little bit careful with this because even though we're adding another 5 straight lines, we're actually only adding another 4 arcs to it. So while we start off with 5 to 8, and that's our first pattern, pattern A, in pattern B, we've got 10 straight lines, but we've actually got 12 arcs. Okay, hopefully that'll make sense to you that we've built up these 12 arcs, okay, in 3 rows of 4, but we've added another 5 straight lines to it. Okay, so we can then carry on with that until we get to the point where we find 2 numbers where they're in the ratio of 10 to 9, okay, and then it'll tell us how many rows have been added. So this is the second row, okay, and then we've got 15 to 16, we're going to have 20 to 20, and then we're going to have 25 to 24, okay, and then we're going to carry on again, and we're going to get 30 to 28. It's starting to get a little bit interesting here. I'm looking for that 10 to 9 ratio, okay, and I think I'm getting quite close to it. So 35 to 32 and 40 to 36. Now guess what? That ratio, if I divide both sides through by 4, I'm going to get 10 to 9. Okay, so I've actually added a further 6 rows to this pattern. So from pattern B, I've added another 6 rows. So 1, 2, 3, 4, 5, 6. So 6 rows, and that would give me the answer to this particular question. Okay, so on to question 14b, and it says a different pattern is made using 20 straight lines and 16 arcs, okay, and the 20 straight lines cost £12. Well, that's great, because if they cost £12, then the price per straight line is going to be £12 divided by 20, which actually works out as 0.6, or if you prefer, I'd rather write that as 60p. So it's going to cost 60p for each straight line, okay? And then it says the cost of one straight line to the cost of one arc is 2 to 3. So in other words, the cost of the arc is 1.5 times more. If you like, it's 3/2 times more. Okay, so all I'm doing really is I'm saying, well, in that case, the cost of the arc is going to be 60 times 1.5, which is going to be 90p. Okay, so I've got the price of the straight line, the price of the arc. Okay, hopefully that's all right for you. If there's a 2:3 ratio, it means the cost of the arc is going to be 3 divided by 2, which is 1.5 times more. Okay, hope that's all right. If there's any query with that, please do add a comment below. Okay, so if I want to work out the total cost of the metal, I can just add those two costs up, because what I've got is the straight lines is going to be 20 times 60p. Okay, and then the cost of the arcs is going to be 16, because it tells us that we need 16 arcs times 90p. If I add all of that together, put in my calculator, I'm going to get a total of 2640 pence. So if I want to convert that to pounds, I'm going to write that as £26.40. Okay, hope that's all right for you. Please do stop the video, have a go at each of these questions yourself. Let's move on then to question number 15. Okay, so question number 15, it says a biased dice is thrown. So biased dice is thrown 200 times. Work out the expected number of times the score will be odd. Okay, well, let's have a look at the number of times that the score will be odd. Is going to be this one here, this one here, and this one here. If it's thrown 200 times, we're basically saying that the number of times it would land on an odd score is going to be 0.25 plus 0.15 plus 0.30. Add all of those together, is going to land on an odd score 0.7 of the time, if you like, or 70% of the time. So to answer the question, if it's thrown 200 times, it's going to be 200 times 0.7, which is 140. So I would expect it to land on an odd number 140 times out of 200. Okay, let's have a look at the next question, which is going to be question number 16. I'm going to aim to just do a few more questions before we finish this particular video. So the value of y is 20% more than the value of x. All right, well, it's a little bit trickier, that one. What we're basically saying is that if x is 1, y must be 1.2. Okay, and again in there we're just sort of it's a little bit tricky to see because you've got a decimal. So if I change that to 10 to 12, hopefully you can clearly see that if I divide both sides by 2, I'm going to get 5 to 6, and that would be the answer to that particular question. Okay, so let's have a look then at question number 17. Here is a triangle, circle the correct equation, and we've got all this, all these different sine rule applications. All right, probably the way to do this is actually just to work it out for yourself. Okay, so what I'm saying here is that if I call this A, which is the x bit of it, then it follows that the opposite angle to that is capital A over there. Okay, and if I call this B, the opposite angle is capital B. Okay, and if I work that out, I can say that actually x over the sine of 42, so it's going to be that one or that one, is equal to 15 over the sine of 104. So it's actually this one here. Okay, it's one of those questions, I appreciate it's only 1 mark, but it is quite important, so it does take a little bit of time to kind of work through sometimes. Okay, so we'll do question number 18, and this is going to take a little bit of time because question number 18 is a very long question that's going to require just some work on it. And what we're saying is that you've got this tunnel for a toy train, and what we're going to have to do is work out the total area of all 6 faces of the tunnel, and you've got to give your answer in terms of pi. Alrighty, okay, so what I'm going to do first is I'm going to look at AD, which is this along here, if you like, this along here, as actually being a whole circle. So what we've got is a whole circle with A to D as actually the diameter of it. Okay, so hopefully I'll be able to do this on the video. So I've got circle AD. All right, so if we look at circle AD and we want to work out the actual area of that circle, what I need to do is to work out pi r squared for the whole circle, but bearing in mind it's a half circle, so I'm going to divide it by 2. Okay, so all we're doing at this particular moment in time is we're working out this semicircle where A and D is there. Okay, so if I look at the dimensions that I've got available to me, that's actually going to be 100 pi over 2. Now that's because r squared, r is 10, so r squared is going to be 100, so this bit along here is 10. All right, so that's going to give me then 50 pi. Okay, for that circle, if it was completely shaded in. You won't be able to get a train through it, but it'd be completely shaded in. Okay, so we then need to work out the circle, or semicircle if you like, BC. And I'm going to use exactly the same idea, but this time what I'm going to do is work out this middle bit. And when I've taken one away from the other, I should be in a position where then I can work out the shaded area of the front face of the tunnel. Okay, so that I'm going to apply the same idea, pi r squared over 2. Now in this particular case, it's got a radius of 7, so that's going to give me 49 pi over 2. So if I break that down, that's going to give me 24.5 pi. All righty. So therefore, the shaded area is going to be the big semicircle, take away the small semicircle. So if you like, I can put something like this in here. So the shaded area is going to be 50 pi minus 24.5 pi. Okay, and that's going to give me then 25.5 pi. All right, so that's one bit of this particular jigsaw, but you have to remember also that it's both sides of the tunnel. So you've actually got this kind of situation where you've got a tunnel like that, okay, and we've worked out this shaded area, but it's also at the other side as well. So actually shaded both sides, so both sides is going to be 25.5 doubled, which is going to be 51 pi. Okay, all right, so that's fairly okay. Hopefully if you can see that as we work through it. All right, then let's have a look at the other bits and pieces that we need to add on to this. Well, we've got a base. Now we know the tunnel itself is 30 centimeters long, so the base on one side, and what I'm doing here is I'm just basically working out the very bottom area of this half pipe, if you like. So it's that bottom area. The base is going to be 3 times 30. Okay, so that's going to equal 90. Okay, but again, I've got both bases. Okay, so both bases, and that's going to be 90 doubled, which is going to give me 180. Okay, so hopefully that's all right. And then a couple of other things that we need to look at as well. So I've got both my sides, so that's the front and the back, and then I've got both my bases, and then I need to look at the inside. I need to look at then the outside. All right, so the inside is this little bit that kind of goes inside the tunnel, is that bit in there. Okay, so it's this little bit that the actual train is going to go through to. Okay, so the first thing is that the inside okay, of BC, which is, if you look at the diagram, we've got this central bit here, is going to be, now again, we've got to be careful about this, it's not pi r squared, it's actually this perimeter of a circle, the circumference of a circle, which is going to be pi d, and then I'm going to divide that by 2, okay? If I get that, it's going to give me this length around here, okay? And of course I need to multiply that by 30 because the tunnel itself is 30 centimeters long, okay? If I plug this into my calculator, what I'm going to get is that the value of pi stays the same, but the value of the diameter is now 14. Remember, it was initially 7 as a radius, so it's 14 as a diameter, so it's 14 pi over 2, and I'm going to multiply that by 30. Okay, so therefore the inside is going to be 210 pi. Okay, so I'm in a situation now where I've got this, okay, I've got this, and I've got this. All right, so my last little bit that I need to do is I need to again work out this pi, but this time it's the outside area, okay, so it's all this area along here, okay, apologies for my drawings, okay, but the outside is going to be, I'll call it AD, okay, but hopefully you'll be able to see what I'm talking about from the diagram, and that's going to give me, again, I'm going to use pi times d over 2 times 30, so that's going to give me 20 pi. So remember, the radius is 10, so therefore the diameter is going to be 20, divided by 2 times 30, multiply that through, and you're going to get 300 pi. Okay, and that's the last little bit of this particular jigsaw, that when I add all of these together, I'm going to add this value of pi plus this value of pi plus this value of pi. Don't forget that I'm going to add on to the very end. So when I add these three together, what I should get then is 516 pi plus 180 centimeters. And that's actually the exact answer in terms of pi. Okay, I hope that's been all right for you. I hope it's come across on the video okay. This is the end of question number 18, so we're actually going to stop there. I hope you've enjoyed this particular video. Please do have a look at the next video in the playlist where we'll be hopefully finishing this particular paper off, and I look forward to seeing you inside the next video.